So this question is from J.L. Merriam, the book that I use. Dr. Amiril, who is the coordinator, he don't use J.L. Merriam. He is using a book from Hibbeler. Look at the Hibbeler book when do the exercise. But in my class, I always use the Merriam book because of Merriam book. I think give a better explanation on topics. Still, please use Hibbeler if you want. If we separate the component of the system, we have the lower link C and D. Link DB. We have vertical bar AB. Actually, we have stationaries, fixed point CD, and then we have C point. It is like a bearing block. The first thing when we want to solve the second law of Newton is to draw the free body diagram. We have to identify the coordinate system. For solving the velocity or acceleration and force, it does not matter where you want to place the coordinate system, except NT. The NT coordinate system or S coordinate system requires you to know the path of system. Let's say we have A and it moves we have G, it also have the same trajectories. Just consider half of it. And then we have B. So for G, we cannot see, and they are moving in circular motion. For G, from our knee, we can also represent an imaginary line here. Let's say F. It's not there, but let's see if for S coordinate system or NT coordinate system follow its own path. And at any location, it has its own radius of curvatures. We have to attach the coordinate system to the body for velocity and acceleration. And we can place the initial frame of reference at any location that you like. one of your friends suggests that the origin should be placed at C. When we look at a certain angle, when it's moved from S to S0 to S, so when we consider at this location, the velocity is moving in that direction. This one is also in that direction, this one in that direction. Our coordinate system will be like that. That is T, and it's always pointing toward the center of rotation, so this one will be N. So that's BD and the coordinate system. We have point C, we have this one is X, this one is Y, and our system is moving in that direction. When at R, our velocities will be defined at this location, X and Y, for A, and from G, in that direction, it's Y, and for B, X, and Y. In whatever motion that it takes, we are always referring to the origin for the position vectors. This one for second one, and that one. There is E. We have R, A, R, G, and R, B. If you are looking at the spherical polar coordinate system, have theta 1 there, A, and then we have theta G, and then we have theta . In order for us to evaluate the position vectors, the velocity or acceleration, we have to include this information, and become so many unknowns in the problem. The selection of coordinate system, we find that if I are using the XY coordinate system, we introduce with many variables in the equation. And if we are using a spherical polar coordinate system, we have to determine the radius and different angles there. You can solve this problem, but it takes a lot of variables. So the most simplest way to solve this problem is using the coordinate system, because it is in this normal and tangential coordinate system, the motion of variables here, the points A, G, and B, they are sharing the same magnitude of radius of curvature. So we're going to use that coordinate system. Again, I just want to remind again that the reason why we use anti-coordinate system, because the variables is less, then we can solve it more easily compared to the Cartesian and spherical polar coordinate system. You can try, you can do it as an exercise for your own benefits. And then the second advantages of using the normal and tangential coordinate systems, that at each point on the vertical bar, they are having the same radius of curvature.